Discussion question number 3. So in this question, we're tasked with this equation or this function, the SIR model, that can allow us to approximate the number of infected individuals of a certain virus or infectious disease. So we are in this problem. We are given two tasks. The first one is to find an expression that will yield the time at which the number of infected individuals in the population has reached its peak, and the second is to then find how many days will the peak occur and how many individuals are infected at the time of this peak. And so, dealing with the first task first, we're trying to find an expression that will yield the time at which the number of infected individuals is at its peak. And so, whenever we talk about a peak, we're talking about an absolute max. And according to this equation, in order to find an absolute max or min in calculus, we want to find the derivative first. And that's exactly what we do here. We find the derivative of this equation. And so here we use the chain rule and the product rule in order to get down to this final derivative down here where the mouse is. And now once we have this, in order to locate our absolute max, which is our peak and what's going to give us the expression for the peak, we need to set this derivative then equal to 0, because at any max or min, the slope of the point is 0. So we set it equal to 0, and then we do some simplification, and we get this expression for the time. So it's going to be the natural log of b minus c over c times k over b minus c. Okay, so now we can deal with task number 2, which is finding the amount of days the peak occurs. And that's pretty simple too. We just plug in the constant that we're given, which is k, b, and c. So b, which is the rate of infection, we plug in for 0.28, and c, which is the recovery period, which is 0.2, over, and in k, we have to do a very simple calculation, which is just k is told to be the ratio of infected versus susceptible individuals. So we're told there's 100 infected individuals and there's 100,000 individuals. So that would be 100 divided by 100,000, which will give us 0.001. Okay, so after doing this, then we get 74.89 days, which we can approximate to 75 days, but we're going to use 74.89 days in our next calculation. So then to find the amount of individuals that are infected at this peak, we need to go back to our original equation, which gives us the number of infected individuals. So then we plug in 0.001 again for K, 0.28 in for B, and 0.2 in for C, and we get this long equation that now has a bunch of numbers in it. And after simplifying that down and doing all the calculations, we get that at day 74.89, which is at the peak, we have 12,363.20 infected individuals. But seeing that we cannot have 0.2 of an infected individual, we just round it to 12,363 infected individuals.